Alright. If acceleration of an object is 0, does this mean that no forces are acting on it? Well, the answer is no, but let's try to pick the multiple choice that's right. But first, here's an example of an object that has forces on it, but it's not accelerating. A box that's standing still has a normal force, and it has a weight. So there's forces acting, but the acceleration is 0 because it's not moving. So let's see what choices actually work there. Well, this is clearly a distractor, and not necessarily only if the object is not moving. So let's see. So both D and E work, but maybe we can get something that captures both. So not say the forces balance. The forces balance and they cancel, and then the total force is 0 is really the best answer. So this is all just subtle differences in phrasing. Choice C really captures the idea that forces balance, they cancel, and the total force, which means you add up forces and they sum to 0. So this is really the best way of saying it. And then for number 15, let's draw the free body diagram of this object, and we're told that that F2 is not the friction, so we're going to have a normal force, we're going to have the weight, we're going to have F1, and then we'll have F2, and we'll have a little friction force as well. Now it says, assume that we're pulling with maximum force needed just before the box moves, which means it's not moving. Let's go ahead and calculate that. So we know that n minus fg equals 0 because we balance vertically. And then horizontally, if it's not moving, that means we're balanced horizontally. So we set up the equation as f1 minus f2 minus f equals 0. So that's going to be 30 minus f minus 10 minus the friction equals 0. And so when I simplify, that's going to give me 20 minus f equals 0. I add f to both sides, and I'm getting a friction force of 20 newtons. Now, we get the box to move at constant velocity, so the forces are still balanced. We want to know what F1 equals now. So using this free body diagram from above, which will actually work again, we have F1 minus F2 equals 0. But now we don't know what F1 is. We know we need to write F1 minus the friction force of 10 minus F2 staying 10. And so we end up getting balanced forces, and that gives us an F1 of 20 newtons in that case. Now the last part, we say that this is our setup. So we have F1 minus F2 minus F, but now they don't balance. So since they're not balanced, that means this equals m times a. We're given a mass of 10 kilograms, so we have 30 minus 10 equals 10 times a. That gives us 10 equals 10 times a. And when we simplify, we're going to end up getting a is 1 meters per second squared. By the way, I see so many people cancel 10 divided by 10, and because they cancel, they want to put 0. Come on, man. Don't be that way. So a is 1 meters per second squared. So that, I believe, is the last part of our practice exam. So I'll post these videos and have this PDF solution available on Haiku soon.